Board today, and away we go. So last time we did the chi-square test of goodness of fit. Today is going to be the test of homogeneity. And so what happens with homogeneity, and we're going to use with a single variable. So a single categorical variable, but we're going to do this from two different populations. And basically we're going to see, do they match up? Are they the same from the two populations? So instead of testing our goodness of fit against something that's already known, we're going to do the same thing essentially, except we're going to do it with two populations, is the goal. So away we go. Assumptions, we have our chi-squared formula. All that's going to remain the same. The only thing that changes here is how to figure our expected counts. To figure our expected counts, we're going to tend up to, we can go through the hand calculation of it. But the shortcut to it is take the row total times the column total and divide that by the table total. And when we get there, I'll hopefully have a better idea. And actually, we do this. The only need to do this is for a a multiple choice question. And when they ask you, well, what is the expected count? And this prevents us from actually having to do a complete chi-squared test, because my calculator is actually going to give me the expected outcomes. And we'll get to that in a second. The other thing that changes here is going to be my degrees of freedom. My degrees of freedom is now, because I have two populations of MPOD. So we're going to do row -1 and column -1. Um, excuse me, to figure out that degrees of freedom. Okay. Or cover up one row, cover up one column, and count the number of cells that are left. But here we go. So our hypotheses look something like this. Then the proportion of the in context that falls in each category is the same for each population, or then my alternate is they are different. Okay, so they are the same, they are different, is how we're going to go about writing that. So our first one here is an urban economist wanted to determine whether the region of the United States resident lives is associated with a gender of level of satisfaction with life. He randomly selects 150 residents 18 years or older from 4 geographic regions of the U.S., East, South, Midwest, and West. He asks, are you satisfied or dissatisfied with the way things are going in the United States at this time? Okay. Oh, that's nice. We're going to do it because it's a categorical variable. We're going to be asked to perform a chi-squared test. If I look here, the satisfaction ratings are the same for all 4 regions. It actually gives me satisfaction ratings are not the same. It gives me my null and my alternate hypotheses. Okay. So again, okay, phantoms is doable here. If we want to continue to do phantoms, I'll write it out to the side there. So again, because it is a chi-squared, it is categorical variables. That's telling me I'm going to do a chi-squared test. So just remember from Monday, when we write down on the AP exam, I just want you to write down chi-squared test. Okay, they don't need to know that it's independence, homogeneity, or goodness of fit. However, for me, I want to know if you know. So that means in parentheses out to the side, we're going to write this down. And in this case, it's homogeneity. Okay, so just remember that little thing there as far as for the AP exam, just write down that. For my exam, I need to know that you know what we're doing. Assumptions are going to stay exactly the same from yesterday. So there's 4 that we have to meet. Okay, a random sample of people. And if I go up in the text of the problem, he randomly selects. So there we go. We got that checked off. Okay. Category counts greater than 1. So yes or no. And actually north, south, east, west, all that fun stuff works. So we're good. Expected counts. We haven't got to that yet. So for right now, I'm going to put greater than or equal to 5, but I just know that I need to come back and check that. Obviously, again, they're not going to give you something where you're going to hang up on, so you're probably safe to just write it down and move on. And lastly, we're going to be independent. in the fact that 600 is less than 10% of the all peoples. Okay. All right, so we're doing this chi-squared test of homogeneity. We need to test it on some type of alpha level. We'll call it 0.05. Okay, so I think we're ready to go about doing it on our calculator, because our calculator is going to do all the heavy lifting on this one. Okay, so before we get there, though, let's talk about how am I going to find in a chi-squared test. You all, no matter which test it is, whether it's goodness of fit, homogeneity, or independence, you have to list the expected outcomes. Okay, so up above, we said all these expected outcomes were row total times column total times table total. So what we're expecting is, in other words, we're expecting everything to be independent here. Okay, meaning it's the same for all, the proportions are going to be the same throughout. Meaning if I want to know what proportion of all people were satisfied, that would be 337 out of 600 people were satisfied. Well, what has to happen is in each subgroup, that means that proportion is going to stay the same as well. So that is, I need to know what is this expected outcome here. So we're going to call that X, and that's divided by 150. So if we look at, if we were to solve this, we would just cross multiply this, okay? Meaning we would take 337 times 150. So I'd multiply those together. Okay, and then what happens, I would multiply the X times the 600, and then I'd have to divide over the 600. So I'd multiply the two circled numbers divided by 600. Now, if you talk about what those numbers are, 337 is my row total. 150 is my column total. And 600 is my table total. So when I go back to this little formula that we have up here, okay, row total times column total by table total, in reality, you are just cross multiplying. Okay, so that's what it is. Okay, because we're expecting that proportion to be the same throughout. So in this particular case, of course, I don't have a calculator handy. My headphones are falling off. I hit record, didn't I? A chat. What's in the chat? I can show you. I will show you. So when I jump out to my calculator here in a second, I will definitely do that p-value so you can do number 1 on your homework. Here, I'm doing 150 times 337 divided by 600 is 84.25. Now, I do not want to take time to figure out those 6 calculations. That would actually take a long time. So the good news is my calculator is going to do this for me. Okay, so let's jump out to do our calculator, and we'll pause and we'll do number 1 on your homework as well, and get that looked at. If I can find my calculator there. Okay, so on number 1 of your homework, you were given a chi-squared value and a degrees of freedom. And I don't remember, do I have that handy? I have that handy. Okay. So what happens is it's hard to do. So let's actually, the 2 ways to do this are our table in our formula sheet. So actually I'm going to jump out and look at that first. So I'm going to jump out and we're going to look at the formula sheet. Okay. Let's go look at chi-squared. Okay. So in number 1, you were given a chi-squared value of 7.5 with 2 degrees of freedom. So here's my degrees of freedom. There's 2. So we're going to keep going over until I find something close to 7.5. So here is 7.38. Here is 7.82. So that means that 7.5 falls somewhere here in the middle. So that means if I come up here to my probability, that probability is somewhere between 0.02 and 0.25. All right, so 0.23, maybe something like that. Okay, that's using my table to get a probability. It's not very specific at all. Okay, but it would allow us to fail to reject or reject. Okay, so that would allow us to do that. okay, which is basically all we really need that probability to do. However, I do have my calculator available to me. So let's go out to our calculator. If I hit second and I go back to the distribution area where we have the normal CDF, PDF, all that fun stuff that we've been doing, okay, if we scroll down, we see that options 7 and 8 are a chi-squared PDF and a chi-squared CDF as well. If there's anybody rolling with an 83, make sure you flag me down after class because we need to talk about how you need to get a goodness of fit formula for your calculator. Anyway, we're going to choose this chi-squared CDF, okay? All right, so what happens on a chi-squared test? A chi-squared test is always going to be right-hand tail, so I'm going to clear that out. In number 1A on your homework, it gave you a chi-squared value of 7.5, so I entered that. We've got a large number. I'm not going to rewrite the 1E99. I have 2 degrees of freedom, and then we're going to paste, and then we're going to hit enter, and there we go, 0.023, 0.024 rounded. And we estimated it at 0.025 because we were just kind of guessing between 2 values. So 0.023, I think is what we said. Okay, so that's how we're going to find a p-value from a chi-squared value, either in your calculator or from the table. All right. So now let's jump out to doing number 1 in our homework. Now, I'll take us a long way there. So if we go into stats and go over to test, again, we're going to scroll up. There is a now we're going to be performing a chi-squared test. Okay, so I'm going to hit enter. Now, the difference now is if you look, we don't have L1 and L2. Okay, they have a matrix A and a matrix B. So when we do a chi-squared test, either homogeneity or independence, we actually have to use matrices in our calculator. So I'm going to exit this and I'm going to go back into now I'm going to open up my matrix area. Okay, now I have these entered ahead of time, so you didn't have to take time to watch me enter data. Okay, so if I look at if I go over to edit and I choose number 1, this should be the totals that are in that matrix. So in entering a matrix, if we haven't entered a matrix before, you want rows first, then columns. So that's why this is a 2x4 matrix, because I had 2 rows, yes and no, and I had 4 columns, the east, south, midwest, west, and all that fun stuff. And we just entered those numbers. So we don't put our table, we don't put any totals in there because the calculator is going to do all that fun stuff for you. It is just those 8 numbers. Okay. So now we're going to go back to stats. I'm going to go over to tests, and I'm going to go up and I'm going to use that chi-squared test. Okay. So there's my chi-squared test. I have it stored in matrix A. Now, this is the nice part about this. You do not have to do the expected matrix. It is going to make the expected matrix for you. So that is nice. Okay. So we're going to come down and I'm going to hit calculate, and I'm going to hit calculate. Okay. So my chi-squared value is 3.54. My p-value is 0.315, and I have 3 degrees of freedom. So let's talk about how we're going to get how we use all those things. Okay, so hopefully you have those things written down. Actually, I'm getting ahead of myself because what we need here to keep on moving is we need all those expected values, because that's actually where we were in our test. Okay, so I need to write those things. I have those things written down. Okay, and I'll come back to those. But right now, I need to go back to my notes, and we need to look at this part of it. So now, I said that what we're after right now is we're trying to find expected values. So I'm looking for the expected value of no. Okay, well, I know that it's going to add up to 100. No, I digress. So I know this is going to add up to 150. So I know this is going to be 65.75. Okay, but I don't want to do that. Let's go back to our calculator. Okay, I'm going to go back into my matrix area. Actually, I need to quit this first. I am going to go back into my matrix area, and I'm going to go down to matrix B, which is where it wanted to store my expected values. So I'm just going to hit enter. Okay, and so it brings up matrix B. I'm going to hit enter again, and there are going to be my 8 expected outcomes. Okay, as far as the nice part about the actually I wasn't paying attention to the nice part about this problem, because all of my column totals were 150. This was a two calculations because everything was the same all the way across. My entire top row was 84.25, which I rounded to 84.3. So maybe we'll go back and change that. My entire bottom row was 65.75. Okay, so let's go back. Oh, I wrote down 84.25. Okay, what was the other one? 65.75. Okay, so we didn't, it's nice to go through that process, but this was actually unique one where it was going to be the same all the way across there. The expected values are the same, but we have to list the expected values all the way across there. So we're going to fill all those in. Okay. All right. So now we needed the expected values because we are trying to come up with a chi-squared value. So if we're going back to again, there's no p in a chi-squared test. We were given hypotheses. We didn't have to write those. Okay. We've already done our assumptions. We have named this test. Now it's coming up with that test statistic. So the test statistic, it's the same exact process as it was as goodness of fit. I observed 77. I expected 84.25. I'm going to square that, and I'm going to divide it by the expected, which is 84.25. So there would be 8 of those calculations that we would need to put together. Okay. I don't want to do all 8 of those. I'm going to go to my last term, and my last term is 67 minus 65.75 squared divided by 65.75. And now we'll just go with the calculator, okay, and what we did with that. So in my calculator, the things that we needed to write down was the chi-squared value of 3.54. We haven't got down my degrees of freedom yet, okay, so my degrees of freedom. If we go back to the beginning of our notes said degrees of freedom was row minus 1 times column minus 1. So again, back to this matrix, there were 2 rows and there were 4 columns. So we're going to take 2 minus 1, which is 1, and we're going to take 4 minus 1, which is 3. So that means we're going to take 1 times 3. So the degrees of freedom is 3. And if you remember from the calculator output, it said it was 3. So there wasn't any issue there as far as there's no funny, a couple of the tests give you funny degrees of freedom. This one is not going to. Okay. So the last thing we need to roll with is we needed to have a p-value to go with 3.54. So again, just so we're kind of understanding what we're talking about, we have 3 degrees of freedom and 3.54. So let's come back up here to that curve. Where are you, curve? Okay. So we had a chi-squared value of 3.54, which puts us right there. When we talk about a chi-squared value, it's the area under the curve. We had 3 degrees of freedom, which is that red curve. So starting here, we're after this area right there. That's the area that we're trying to find. So that's why my p-value turned out to be fairly large at 0.316. Okay. Whoa. So we have found a test statistic. We have obtained a p-value. We're ready to make a decision. So again, we've done tests now for feels like 2 months. Okay, actually, it kind of has been. But anyway, so since our p-value is less than alpha, we will read. Whoa! Where am I going here? It is not less than alpha. Since my p-value is greater than alpha, we will fail to reject HO. There is insufficient evidence to suggest satisfaction ratings are not the same. For all 4 regions. Okay. Excuse me. All righty. Let's move on to next one. We only got two pet sample problems to knock out today. So here we are. So let's see. I need to remember next year to not center these, but that's okay. All right. So some natural health experts claim that St. John's wort works well as a prescription medicine in the treatment of depressions for adults. To study this, researchers recruited 338 patients willing to participate in the study. The patients were randomly assigned to one of 3 treatments, St. John's wort, Zoloft, or a placebo. The researchers then analyzed the results in the display below. And that's where it went. They didn't ask us any questions. So I guess that's on me. I didn't make that clear. All right. So we want to see, is there a difference between the treatments for depression as far as St. John's wort, Zoloft, or a placebo? Is there a difference in the results? Okay, so we had a full response, a partial response, or no response. So I'm not for sure exactly what scale they were measuring that on or anything like that. So we were trying to see if those are equal. Okay, so again, this is going to tell me that I'm after a chi-squared test. We're going to test for homogeneity. And when we can fill out, we have an alpha level of 0.05, and we can write in our degrees of freedom here if we wanted to. I know that I have 1, 2, 3 columns, and I have 3 rows, and so that means 2 times 2 is 4. Okay, so my pen die. There it is, 4. Okay. Now I know up front that I'm going to have to get this into a matrix in my calculator, and again, to save time, I chose to enter this into my calculator already. So if we look at this and I switch and go look at my matrix, at least I need to double check that. I am pretty sure that I did. We're going to go over to edit. I'm going to edit matrix 3, and there's 17, 16, and 70. So that means that's got my, yeah, that is the correct matrix. Okay. So we're going to go stats. We're going to go over to test. I'm going to go up to that chi-squared test. Okay. Now in this case, though, I don't want matrix A. I want matrix C. So matrix names are still in matrix. So I'm going to go shift and I'm going to go back into matrix. And in the names area, I am going to select matrix C. So there we go. That changed that to a matrix C. Now, again, if you go back to my expected outcomes are from the other matrix. So it's still a 2x3 matrix. Okay, so this is not the same size, but it doesn't matter. Your calculator is just automatically going to ramrod that in and over and take care of that stuff. So this is the stuff that we have to write down or just be able to come back and find really quickly. We have the chi-squared value of 14.37. So that's actually pretty high. Yes, that p-value is representative of that. It's a 0.006. My degrees of freedom was 4, so that means that it was even less skewed. Okay, so just a lot of things were going into this. So that means that I am ready to. I'm going to go ahead and take care of my expected values now. So we're going to go back to my matrix. I'm going to quit out of this. I have all that written down. I'm going to quit out of this. And I'm going to go back to my calculator. Actually, we'll go into our matrix. Now, there's a couple of different ways we can look at now I need to look at matrix B. And if you noticed before, now matrix B is a 3x3 because it has to match up with that. I'll just go over to edit this time and select matrix 3. No, I don't want to edit matrix 3 because okay, try again. I'm going to edit matrix 2. Or B, there we go. So there's all my expected outcomes, 27.73. 16.76, 58. Now, those are rounded off to 4. That's just, again, I think somewhere in the notes it said never round. It's one of those things that, I don't know, never do, but it's okay. I've never been too whipped up on it. So here we go. Let's write all these down. So we got 27.73. We got 16.76. We've got 58.51. We've got 32.04. Got 19.36. We got 67.6. We've got 31.23. 18.88. And 65.89. And there's my expected outcome. So I've taken care of all that, you know, the ugly, the time consuming part is done from, well, time consuming. A hypothesis test is just time consuming, period. Okay. All right. So again, we can all write phantoms out here. I don't think I'll check mark this one, but just remember, we can always follow phantoms. We need to have some hypotheses. So my null hypothesis is going to be response rate is the same for all groups, for all treatments. My alternate hypothesis is the response rate is not the same for all treatments. All righty, let's take care of those 4 assumptions. Okay. Now here again, pay attention to, it's told us up here, we were randomly assigned. So when we say this, we have a random assignment. And we need to have a random assignment of what? Peanut butter and jelly sandwiches? No, random assignment of treatments. Okay, we have category counts of greater than 1. Oops, here, I'm getting too sloppy. We have expected counts, which we actually took care of early for once, greater than or equal to 5. And independent, again, independent, I'll cross that one out. You don't have to write that crossed out. With an experiment, we don't have to worry about independency. Okay. All right. So we've determined this is a chi-squared test. We've already wrote that down. So somewhere, make sure you get this name. Okay. So my chi-squared value, I'm observing 17. I expected 27. That's a large gap. That's again, that's why we did that. So now the question up there is, some natural health expert claim that St. John's wort works just as well. So we're just seeing if it is categories, if it is the same all the way through. So we haven't ruled out St. John's wort. Anyway, I'm babbling now. 66 minus 65.89 squared divided by 65.89. So we did our first and our last term. And we got a chi-squared value of 14.27, which is extraordinarily high. And that was evident in our p-value rolling in at 0.006. Okay, so we have, again, following that process, we've done our hypotheses, we've done our assumptions, we've got a degree of freedom up there, we've got an alpha level up there, so we are ready to just finish this problem out. Since our p-value, this time it's less than alpha, we will reject HO. There is sufficient evidence to suggest response rates are not the same among treatments. So it didn't say, we didn't do anything at all as far as addressing the St. John's wort. We're just saying, being a treatment for depression, we're just saying it's that rate is not the same throughout. But we can look at this and realize that a full response was well below what was expected. Okay, and a no response was well above what was expected. So that's where we would attempt to start going with that. All right. I think I don't, the gummy bears would just be one more example. I don't necessarily, we miss me. I don't even know if I'll do that in my other classes today, even though we counted that data yesterday. I think I will just pull the plug on myself here and we'll call it a day. Something in the chat. On the test, yes, you need to, you would have to write all yes, that is part of my rubric. You would miss points if you did not write all the expected values on the test. Other questions?